Good morning, everyone. My name is Professor Swapnil S. Surke of SND COE and Research Center, Evla, of Department of Electrical Engineering. Today, we will discuss the topic of the subject Advanced Microcontroller and Embedded System of the Unit 1, that is Introduction. In this subject, we will discuss the topics like data memory organization, then program memory organization in detail. First, we will discuss the data memory organization and then program memory organization. In the computer, there are various memories involved for the functioning of the computer. In this topic, first we will discuss the topic of memory organization in computer architecture. The memory is organized in the form of a cell. Each cell is able to identify with a unique number called address. Each cell is able to recognize control signals such as read and write generated by CPU when it wants to read or write address. Whenever CPU executes the program, there is a need to transfer the instruction from the memory to CPU because the program is available in memory. To access the instruction, CPU generates the memory request. Then the second point is that memory request. Memory request contains the address along with the control signals. For example, when inserting data into the stack, each block consumes memory RAM, and the number of memory cells can be determined by the capacity of a memory chip. Example of this memory request is that, suppose we take the example like that, find the total number of cells in 64K into 8 memory chip. In this problem, size of each cell is 8. The number of bytes in 64K is 2 raised to 6 into 2 raised to 10. Therefore, the total number of cells is equal to 2 raised to 16 cells. With the number of cells, the number of address lines required to enable one cell can be determined. Then the next topic is that word size. It is the maximum number of bits that a CPU can process at a time, and it depends upon the processor. Word size is a fixed size piece of data handled as a unit by the instruction set or the hardware of a processor. Word size varies as per the processor architectures because of generation and the present technology. It could be low as 4 bits or high as 64 bits depending on what a particular processor can handle. Word size is used for a number of concepts like addresses, registers, fixed point numbers, floating point numbers. Then the next topic is that data memory, that is RAM organization. Data register map with 12-bit address bus, that is 000 to 888. Then divided into 256 bytes banks. Then this data, there are total of 8 banks. Then half of bank 0 and half of bank 15 form a virtual bank that is accessible to no matter which bank is selected. In other words, every memory location is byte addressable. That means each memory location consists of one byte and each location has a unique address. Hence, memory is organized in the order of hundreds and thousands of bytes. Then the next topic is that memory organization in computer architecture. A memory unit is the collection of storage units or devices together. The memory unit stores the binary information in the form of bits. Generally, memory or storage is classified into two categories. That is volatile memory. This loses its data when power is switched off. Non-volatile memory. This is a permanent storage and does not lose any data when power is switched off. Then memory hierarchy. The total memory capacity of a computer can be visualized by hierarchy of components. The memory hierarchy system consists of all storage devices contained in a computer system, from the slow auxiliary memory to fast main memory and to smaller cache memory. Then auxiliary memory access time is generally 1000 times that of the main memory. Hence, it is at the bottom of the hierarchy. The main memory occupies the central position because it is equipped to communicate directly with the CPU and with auxiliary memory devices through input-output processor, that is I/O. When the program not residing in main memory is needed by the CPU, they are brought in from auxiliary memory. Then programs not currently needed in main memory are transferred into auxiliary memory to provide space in main memory for other programs that are currently in use. Then the cache memory is used to store program data which is currently being executed in the CPU. It then approximate access time ratio between cache memory and main memory is about 1 to 7 to 10 times. Then next topic is that memory access methods. Each memory type is a collection of numerous memory locations. To access data from any memory, first it must be located and then the data is read from the memory location. Following are the methods to access information from memory locations. These are random access. Main memories are random access memories in which each memory location has a unique address. Using this unique address, any memory location can be reached in the same amount of time in any order. Then sequential access. This method follows memory access in a sequence or in order. Then direct access. In this mode, information is stored in tracks, with each track having a separate read and write head. Then main memory. The memory unit that communicates directly within the CPU, auxiliary memory, and cache memory is called main memory. It is the central storage unit of the computer system. It is a large and fast memory used to store data during computer operations. Main memory is made up of RAM and ROM, with RAM integrated circuit chips holding the major share. Then RAM. RAM is the random access memory. It of various types. These are DRAM, that is dynamic RAM, is made of capacitors and transistors and must be refreshed every 10 to 100 milliseconds. It is slower and cheaper than SRAM. Then second RAM is SRAM, that is static RAM, has a 6 transistor circuit in each cell and retains data until powered off. Then the third type is that NVRAM, that is non-volatile RAM. It retains its data even when turned off. For example, flash memory. Then ROM, read-only memory, is the non-volatile and is more like a permanent storage for information. It also stores the bootstrap loader program to load and start the operating system when computer is turned on. PROM, programmable ROM. Then EPROM, that is erasable ROM. PROM. And EEPROM, that is electrically erasable PROM, are some commonly used ROMs. The devices that provide backup storage are called auxiliary memory. For example, magnetic disks and tapes are commonly used auxiliary devices. Other devices used as auxiliary memory are magnetic drums, magnetic bubble memory, and optical disks. It is not directly accessible to the CPU and is accessed using the input-output channels. Then cache memory, the data or contents of the main memory that are used again and again by CPU are stored in the cache memory so that we can easily access that data in shorter time. Whenever the CPU needs to access memory, it first checks the cache memory. If the data is not found in cache memory, then the CPU moves onto the main memory. It also transfers block of recent data into the cache and keeps on deleting the old data in cache to accommodate the new one. Then the heat ratio. The performance of cache memory is measured in terms of a quantity called heat ratio. When the CPU refers to memory and finds the word in cache, it is said to produce a heat. If the word is not found in cache, it is in main memory, then it counts as a miss. The ratio of the number of hits to the total CPU references to memory is called hit ratio. The formula for the hit ratio is equal to hit divided by hit plus miss. In associative memory, it is also known as content addressable memory, that is CAM. It is a memory chip in which each bit position can be compared. In this, the content is compared in each bit cell, which allows very fast table lookup. Since the entire chip can be compared, contents are randomly stored without considering addressing scheme. The chips have less storage capacity than regular memory chips. Then the second type of memory organization is the program memory, that is PROM organization in the computer system. The program memory is a non-volatile memory, that is permanent storage memory in the computer system. All modern PIC processors use a flash memory technology that allows the program memory to be reprogrammed using a simple hardware interface. It is common to include some kind of programming connector or on even a production product to allow for firmware updates if needed. The program memory organization, the program memory is the place where the user can write the assembly code of his program. Therefore, this is usually the biggest in size memory of the PIC. The PIC 16F88 device has 4K of program memory. Strangely, it can allocate up to 8K of memory, but only the first 4K are physical memory. In PIC18, microcontrollers implement a 21-bit program counter, which is capable of addressing a 2 megabyte program memory space, accessing a location between the upper boundary of the physically implemented memory and a 2 megabyte address will return. The PIC18F 2420 and PIC18F 4420 each have 16 kilobytes of flash memory and can store up to 8,192 single word instructions. The PIC18F 2520 and PIC18F 4520 each have 32 kilobytes of flash memory and can store up to 16,384 single word instructions in it. How instructions are stored in program memory? Program memory is addressed in bytes and instructions are stored as 2 or 4 bytes in program memory. The least significant byte of an instruction word is always stored in an even address of the program memory. An instruction cycle consists of 4 cycles. These are: a fetch cycle begins with the program counter incrementing in Q1. Thank you.